Welcome everybody. We'll just give another 20 seconds for all the other attendees to drop in. So we'll start the session in 15, 20 seconds time. As I can see, the numbers are slowly filtering in from the system. Okay, fantastic. We'll kick it off. Well, welcome everybody to another webinar Wednesday. Today our session is all based around sports stadiums facilities. It's the third of our lighting design sessions, which we've been calling the basics of lighting design. And today, yep, we have a very special session, like I said, based on the sporting sector that we work in. Very quickly, for those of you who've maybe not joined us before, a little bit of webinar protocol. You are all muted. However, there are a number of ways that you can communicate with us. You can type your questions and questions into the Q&A section, and we'll be providing the answers as we go along. There's a chat function as well for you just to welcome everybody to. And then finally, there will be a follow-up email that comes out to everybody with the recording, and especially for these sessions, links to some of the resources that we mentioned throughout the session, as they're really important. As we go through, you'll understand why that is so. There is, as always, a survey at the end. It pops up in a second bar for you in your internet provider. So please, if you can answer those survey questions, we really, really appreciate it. Today's agenda then, very quickly, we'll introduce the presenters. Well, the presenter who's on the call today. I'll do a very quick 60-second introduction to Midstream Lighting. We have people who haven't joined before again, and it's great for us just to give you a quick overview about who we are before we dive into the session today, which will focus on three areas: tennis, football, and stadiums. There are 2 polls on the call, so we'd love for you to participate with them when they come round. And with regards to Q&A, we'll answer them as we go, as well as at the end. So depending on time, we'll try and get through as many of the important questions as we go. And then, like I said, at the end, we'll come back to them and work through them to provide the answers. So, quick introduction. My name is Michael Short. I'm head of marketing here at Midstream Lighting, and I oversee the whole marketing division, the strategic direction, generation, implementation, and distribution of all our marketing and communications. I'm well versed in marketing. I've had a career that's over 10 years long, working across various industries. Now to the more important person on the webinar, your actual presenter today, who is Marco. Marco, over to you to introduce yourself.
Okay, thank you, Mike, and welcome everybody. Hello, I'm Marco Cavallotti. I'm the project manager here at Midstream Lighting. I've joined the team back in September 2016 as a project engineer, a pure lighting designer. And let's say within this 4 years, I've had the opportunity to develop my design skill as well as the management one, becoming the project manager since last year of our design department here at Midstream Lighting. Thank you, Mike.
Great, thanks, Marco. He's definitely underselling himself there, because Marco's designed thousands of lighting projects in his time at Midstream. So you're definitely in extremely capable hands here when it comes to this topic. So very, very quickly, for those of you who don't know who we are, we're Midstream Lighting. We are a full cycle turnkey specialist manufacturer of LED floodlighting systems and solutions. We're experts in what we do, and we work across a number of sectors, including airports, sports, and maritime. And we've been doing what we do since 2010. We manufacture our products, our lighting solutions, right here in the UK, as well as in Romania. It really makes sure that we have the best quality of products, as well as allows us to ship extremely quickly across the world. And we're very nimble and agile when it comes to getting our products available and out to you in the market. Our products, yes, are extremely unique. It's because of our proprietary optics. And what we mean by this is we only design products made for very particular applications and niches. So whether it's sports stadium lighting, airport aprons, our products are only designed specifically for the areas that they are intended. We have an amazing R&D team, all based in Italy, which is where Marco is currently sat. And like I said, we see ourselves as specialists. We're not generalists. We only make products for the applications they're intended for. We also don't just manufacture the products, we're here to provide a full solution to you. So whether that's supporting on lighting design, maintenance, maybe it's rebate incentives, training, education, we really see ourselves as a business to provide a solution, not just a product. And like we've said in all the last previous weeks on these webinars, we really are here to help educate and push the sector forward. And we like to see ourselves more as a thought leader than simply a manufacturer. If you want to find out more about Midstream Lighting, head over to midstreamlighting.com. And I'm going to hand over right now to Marco, who's going to kick the session off. There's a poll coming very quickly, so bear with us on that. But Marco, over to you.
Thank you, Mike. So let's start. The aim of this webinar is like the basic of lighting designs for sports facilities in the stadium. As Mike already told you, the today agenda is a step-by-step process for design of lighting for a tennis court with like two different lighting layouts, a football field, still with two different lighting layouts, and the general overview of a big UEFA stadium with all the lighting requirements we have from the UEFA regulation. Let's start with the first poll. Mike, up to you.
Yeah, absolutely. Oop, that was me clicking forward. So I'm going to fire up a quick poll, guys, before we move on to the next slide. This is a very simple question. It's just to get everyone's juices flowing and get to understand what people actually understand so far about the lighting levels in sport. So the question is, what would the correct lighting level requirements be for a tennis court? There are 4 options on your screen: 50 lux, 150 lux, 500 lux, and 1000 lux. So again, we just want to understand where everybody's at in terms of their level of education. There is a very specific level that we're referring to here that Marco is going to talk about in a second, but it'd be great to understand, to get a view of what people think the correct lighting level would be for a tennis court. We'll give everybody maybe 10 more seconds because we're almost at the full complement of votes. Great, let's end the poll and share the results. So, if I'm correct, Marco, the answer is 500 lux?
Yes, you're definitely correct. And go.
Yeah, so 54% of you got that right. It's fantastic. With a few people dropping in answers in different areas. Marco, great to see that over 50% of the audience do see that understand what the lighting levels should be.
Yeah, definitely. So 500 lux is the requirement we're going to follow also in this session. Just some example: 50 lux could be a loading and unloading parking area. 150 lux could be like a private tennis court for like training purpose. And 1000 lux is definitely something more related to the UEFA regulation, like very high level with camera broadcasting requirements. So we can start with our session. And okay, like here, the first step is to set the goal for our facility. The first one will be a tennis court. We are following the LTA regulations, which is a British tennis regulation. But I mean, the prescription, the step-by-step guide we're going to follow today can be applied to any other different regulation. Back to the LTA, it prescribes the lighting level and uniformity for the 2 main areas of a tennis court, which are the PPA, principal playing area, and the TPA, which is like the total playing area. I will show in the following slide which is the difference of these 2 areas. As you can see from this slide, we have highlighted the recommended values, which are the one we're going to follow. And it's 500 lux average for the PPA and 400 lux average for the TPA, with a uniformity minimum average ratio of 0.7 for the PPA and 0.6 for the TPA. Let's show you which is the difference between these 2 areas. As you can see in this scheme, the total playing area, which is highlighted in green, it's like the outer and includes the outer and the inner part of the court. And the PPA, it's only the inner part of the court. It is highlighted in blue. So just a quick recap. On the green part, we want to reach 400 lux with 0.6 minimum average uniformity. And on the blue part, which is the PPA, we want to reach 500 lux average and 0.7 uniformity. Let's go on. In this session, I will show you like two different approaches. This is because like poles and mass location, as well as their heights, can affect the lighting results on the field. The factors that they can affect are like the glare ratio, the overall uniformity, the spin light control, and the control of the facility. The first one I'm going to show you is the side-lit scheme. As you can see here, it's based on 6 poles, 3 for each side, located at the sides of the courts. Some of the advantages of this layout can be that you can reduce the glare for the players, and this is because you won't have any floodlights which is facing directly the players. So the main beam of the floodlights won't be directly on the players, and you can reduce also the glare outside the court. Disadvantage of this layout could be that this is applicable for a cluster of 2 or maximum 3 courts, because as you can understand, the distance between the poles, if you have 3 tennis courts, the distance between the poles and the central court would be too high to reach the central court properly with the light. With this layout, general height is between 8 or 10 meters. We will use 10 meters for our dialogue session. And the second one, the second layout I'm going to show you, it's the corner and side-lit scheme. As you can see in this scheme, is based on 9 poles, 3 on the sides, as well as the side-lit scheme, and 3 in the center line in between the 2 courts. An advantage of this is that you can use lower columns, which of course are cheaper than taller one. And another advantage is that you can replicate this layout for multiple courts. If you have 2, 3, 4, and so on courts, you can just replicate this layout and you can cover all the courts. A disadvantage of this, it's quite clear because you have to install more poles. So it's more costly to install, and you will need a larger number of fittings to light the same area. The main advantage of this is that you can use 1 cord at a time. It's easy to understand that you can turn off like all the lighting, all the floodlights facing tennis court 2, and just keep on the one facing tennis court 1. But I will show you in dialogues and more in detail. So let's go on and open our dialogues. We have preset some light, some exterior scene, but we will start with an empty scene. A quick note: we are considering the ideal scenario here, without any environmental restrictions, without any neighboring houses or residential. So this is exactly the ideal scenario where the lighting designer can choose the pole location, the heights, and so on. So I understand that most of the time it's not like this. It's a retrofit with existing poles with some of different restrictions. So let's start our dialogues by inserting the tennis court inside our exterior scene. Dialogues has already in his library some sports facilities preset fields. You can see them in the project manager box here. You just have to click in objects and in sport facilities here. As you can see, we have 8 different sport facilities with the preset dimensions and characteristics. For example, the soccer field has a dimension of 100 meters by 64. There are handball, basketball, volleyball, and so on. We are interested in tennis. As you can see in this box, you can see the dimensions, which are standard, 36 by 18 meter. And to insert it inside our exterior scene, you just have to select tennis the tennis court and click insert. Okay, now let me reduce this like this. Okay, as you can see, we have our tennis court already preset in our exterior scene. Dialux regarding the tennis court only consider the total playing area, so the TPA. So we will have to add a new calculation grid for the PPA, but the first step is to rotate the court according to the drawing I've showed, the scheme I've showed you before. In order to do this, we just have to select the tennis court, go on the project manager box here, click on rotation and insert the angle we wanted to rotate the court. So in this case, it's 90 degrees, and as you can see, it's rotated as we wanted to have it. So as I told you, if we open the tennis court here, it's called the calculation grid PA, which is a plane area, but we know that we have to split it in two parts, the TPA and the PPA, total plane area and principal plane area. So here in the name box, we just have to type TPA, and now we have to add the calculation grid for the principal plane area. In order to do this, we will go back in the object box, select the calculation grid. We want to use the calculation grid, and you simply have to drag and drop it inside our exterior scene. And now we have a calculation grid here. Dialux automatically put the new calculation grid inside the tennis box here. So it is already included in the tennis court management here. So the first thing is name it correctly. So we just have to copy and paste this in the name box and change it into PPA. And then we need to set the dimensions. In order to do this, we have to right click here, use the scale option like this, and simply follow the shape of the PPA with the new calculation grid. Like this, for all the dimensions. Okay, so as you can see here, we have a TPA and the PPA calculation grid with all the lighting, the grid points and the preset tennis courts. The first step now is to set the calculation grid according to what is our need. The prescription of the LTA, but most of the sports requirements are for horizontal value at the ground level. So in order to set the calculation grid to calculate this parameter, we have to select the calculation grid and use this manager box here to set up the calculation we're interested in. So if we go on calculation, let me open this. We want to know the horizontal value, not the perpendicular. So we pin the horizontal and unpin the perpendicular. And this is the most important part of a sport lighting design, the real-time calculation. This is a very useful tool from Dialux, which allow us to see to see which are the lighting level for each grid point during our session. I will show you in detail later on this. We are interested in horizontal, and now what we need to say what we want to see in our scene. So we go on display box here. We want to see the values and not the points. The points are like this small square here, and not to be distracted by them, we can just turn it off. Okay, as you can see, we have no floodlights inside here. So all the values are 0. These are our grid points, and these are values in lux. We have to do this also for our PPA calculation grid. So we will follow the same process. So display values, not points, real-time calculation, we're interested in horizontal, and the calculation, we want to know the horizontal and not the perpendicular. Okay, now we have a complete tennis court with the two calculation grid we're interested in, with all the parameter we want to know already set. So what we have to do now is to replicate this tennis court with another one, because we want to do a lighting design for a cluster of 2. So we just have to copy and paste this, and by doing this copy paste process, all the parameter we have set in the first tennis court will be replicated exactly in the same for the second one. So we have to name it correctly. This would be tennis court 2. You can move it easily in your lighting scene, but for tennis purpose, it's very important the location of the 2 courts or whatever sports facilities you have with the coordinates of our exterior scene. This means that we have to select each tennis court and go on the sports side manager box and move it according to the coordinates. The center of our drawing is this 0, x, y arrows, and we want to have the center of the 2 courts in the middle, the center, sorry, of the lighting scene in the middle of the 2 courts. So since the dimension is 18 meter, this dimension is 18 meter, we have to put it on -9 for x-axis and 0 for y-axis, and the same but mirrored for the second tennis court. So 0 and 9 meter. Okay, so now you can see that the center, the origin of our lighting scene is located exactly in the middle of the 2 courts. Now, in order not to get distracted by all of this number, we can turn off the values here by simply right-clicking here, go on display option and turn it off. And we will do the same for the other calculation grids. So turn off, display option, and turn off. We will only use the TPA of the first tennis court. So the next step is to insert the floodlights inside our exterior scene. As you already know, because Paolo explained it to you in our previous sessions, here in this box, in this toolbar, we can select single luminaires, line arrangement, field arrangement, circular arrangement, and the one we're interested in, which is the floodlight arrangement. So we just have to click on here, select the floodlight we're interested in. For this application, our Modus Area 800 is the best one. It has a symmetric optic with the little asymmetry just here. This is due to our lighting shield, which help us to increase the glare control and reducing the upward light ratio. So we have selected the floodlights, and we just have to insert our floodlight arrangement in our exterior scene. As you can see, this is the main one, and this is another important function that Dialax has, which is the symmetry. This means that this is the main one, the main floodlight arrangement. Let me move it here so we can better understand what I'm saying. As you can see, this is the main one, and it is replicated and mirror horizontal and vertical according to the symmetry point, which is this one. So by moving just one lamp here, we can move 4 of them according to the symmetry point. What do we have to set in our floodlight arrangement is the rotation, because this arrow, with this arrow, we can move the main peak of the floodlights, and the software has to recognize where is the main peak of your photometric. Each photometric has its own rotation. So you always have to ask the producer to give you the right rotation for each photometric you are going to use. For our R800 model with this optic, the rotation is C minus 90 and G max. So like this, the software knows that in this point, there's the peak of the lighting source. What do we have to set now is the symmetry point of the floodlights, which should be in the origin here. So we just have to select the floodlight arrangement and use this manager box here to set the symmetry point here. As you can see, this is the position and this is the symmetry point. We wanted to have it in the origin, so it's 0 and 0. And by using this position tool, you can also set the position of the pole, because these represent a pole. For this purpose, we want to have it at 12 meter for y-axis, which is the end of the PPA, and just for an example, maybe 20.5 meter for x-axis. So this is 20.5 and this both is 12 meters. What do we have to do now? The last setting is the mounting height. Here, Dialax automatically select like 12 meter according to the floodlight you're going to use, but we are interested in 10 meters. We want to set it at 10. So what we have now is one pole with one floodlights, which is replicated exactly with the same aiming and same characteristic horizontally and vertically. For this application, we want 3 poles with 2 floodlights each. So we just have to copy and paste this, copy and paste. And by doing this, as for the calculation grid, all the setting we have set will remain the same also for the second one. So this is the new one. We have to put it in the middle of our scene, and we will use always the arrangement box here to put it in the correct way. This is very important because everything here is based on the symmetry. In fact, and this saves a lot of time in the design part because you can design one court and have exactly the same design on the second one because of this symmetry option. So this will be 0 for Y and 20.5 meter. So now we have the central pole with 2 floodlights, of course, having like the Y axis located at 0 at the same quote of the symmetry point. You have 2 floodlights by having just one. And for this pole, we just have to go on the arrangement box and just type number of floodlights. We want 2 floodlights. So now we have built our exterior scene, as you can see here, which is based on, let me just turn on the lights, 6 poles located at the side of the 2 courts with the symmetry point exactly in the origin of the exterior scene. So we have rebuilt in Dialax the scheme I've showed you before, the side lead scheme. Now we can start and go deeply in the design phase. I've told you before that there is a real-time calculation option in Dialax, and now we see what this means. These are the calculation grids points of the TPA. These values are in lux, and as you can see, if I move the peak of the light here or here, all the lux values will change according to the aiming of the floodlights I'm moving. So as you can see here, it's 383, and now it's like doubled because I'm using the floodlights to light this point. Automatically, Dialax highlight the minimum and the maximum level, which are basically the 2 most important values, because the minimum is related to the uniformity, which is the ratio between the minimum and the average illumination level, and the maximum is related to the second uniformity, which is the minimum maximum uniformity. So as you can see here, they are highlighted in purple. 925 is the maximum and 128 is the minimum here in this corner. So the lighting design process has the aim of, as we have seen before, the LTA regulation for the TPA, 400 lux average here and 0.6 uniformity minimum average ratio here. So as we can see, we already exceed the requirement of 500 lux average here, but we are far from the 0.6 uniformity required here. What do we have to do in order to increase these values is to increase the minimum value, since this is the ratio between the average and the minimum. So what we have to do is to use the floodlights we have in our scene to increase the minimum value. The minimum value is here. It's exactly the same here. So we just have to use the floodlights to increase this value. As you can see, by moving the floodlights, also the minimum and the maximum will move all the way within the court. Now the minimum is here, so we can use this pole to increase the minimum value and to cover the lack of light in this area. Now the minimum is back here. We can go back to our summary here. We have doubled the uniformity that we had in the beginning of the design process. We have to go on and increase the minimum values again. So we can just move some of the floodlights in order to increase the minimum here. And okay, we're very close to the required level of 0.6. So we just have to slightly move a little bit of the floodlights still here. And okay, now we have it. We got the requirement recap is 400 lux here and 0.6 uniformity here. Of course, we can increase this value in order to exceed the requirements, which is always a good practice. And so we can just increase a little bit more the minimum here. As you can see now, the minimum is here. Well, now we definitely meet the requirement, 400.6. What we have to do now, these are only the TPA, we have to turn on the TPA grid to see which are the lighting level on it. Most of the time, if the TPA match the lighting requirement, also the PPA will match the lighting requirements. So let's see, right click on the calculation grid here, display option, as I showed you before, display values. And just to not being confused, we turned off the TPA values. Okay, the requirement here was 500 lux and 0.7, and as you can see, we already meet the lighting requirement. We are way over. We exceed the requirement by like 36 lux average and a lot for the uniformity. What I want to show you is that we will have the exactly same values for the second chord because of the symmetry. And I always stress a lot that if with the right model, you can save a lot of time in design, because we have the second tennis court with the same lighting requirement by doing just one court. So what I'm going to do is turn on the values here, display values, and tennis court one is 536.79, and the second one is 535.79. There's a little discrepancy just due to the asymmetry of the light, but as you can understand, it's like 0.01% difference. So what we can do now is to run the simulation by clicking the calculation button here. These are the other exterior scene we have already prepared. We want the exterior scene empty, which was the one we have started with, and just run the simulation. It's very quickly. So what we can see is the light distribution with the false color rendering, which give us an idea about the light distribution over the pitch. In this box, we can set the color scale we are interested in. For example, for the PPA, it was 500 lux. So we can set the maximum, the white color, to 500 lux, and automatically Dialux will interpolate the values from the maximum we have preset and 0 in a color scale. So we just have to click apply. And yes, we can see where 500 lux are reached within the field. As you can see, the most of the light is focused on the PPA, which is the most important part. And we have like darker spots in between the courts where no players will ever play a ball here. So this is the step-by-step guide to build this model with a sidely skin, 6 poles, 10 meter high. What I want to show you is the difference between this approach in terms of pole layout and heights and the corner and side lit scene. So we have prepared already like these 4 scenes. The first one is exactly the same we have just done. Let me show you that we have set like about the same layout. We have set 8 GR observer for each court, and we have done the same with the corner and side lit scene. Let me just show you here. As you can see, we have the 6 poles and the 3 poles in the center line. The difference between these two scenes is that the mounting height for the first, as you can see here, is 10 meter, and the mounting height for the second one, so all the poles here are 8 meters. As I told you before, the main difference will be the glare. and the fact that you can use one core at a time. So we will have lower glare with the side lead scheme with the higher column, and higher glare with the corner and side lead scheme, which is this one, which use 8-meter column instead of 10. We have set, as you can see, exactly the same GR observer within the two scenes, 8 each court. And if we go on the output box here, we select the side lead scene and the GR observer results overview, we can see that the maximum level is like 37, 38, no one exceed 43. The maximum should be lower than 50. If we go on the corner and side lead scenes, we will see higher values. Let's keep in mind 37, 38, and 38, the first three. And here we can see 47, 46, and 46. As you can see here, no one like exceed the limit of 50, but they are definitely higher than the previous, the first pole layout. The other advantage of the corner and side lead scene is that you can use one core at a time. So let me show you in 3D the difference between these and these. So let's turn on the false color and see in 3D. This is a 9-pole with 2 cores all on, so a full mode on. And this one is the half pitch mode on. So what we have done here is basically, let me show you in 2D, which is more clear, I think, is to, let me turn off the light, we have removed basically the pole in this side and turn off all the floodlights facing the tennis court too. As you can see, we still have a compliant design for 100 lux.6 for the tennis court one. And here you can see in 3D with the false color rendering, like the light distribution for the full mode on and the half pitch on. This could be very useful because if you have a cluster of 2, 4, 5 tennis court and you are using only one, with this scheme you can use it and just don't waste energy and power consumption to light something that it's not going to be used. So I think that with this we have finished with the tennis court, and we can go on with the second application I want to show you. Let's get back to the presentation, which is here. And so I want to show you a football pitch. A football pitch has its own regulation, of course, which is the EN 12193. In particular for football field, we have highlighted in this slide the table A21, which prescribe different lighting level according to the class. The class 1, 2, 3 are related to the level of the team, to the level of the pitch, and are required by the customer. For our purpose today, we will follow class 2. The prescription is 200 lux average with a uniformity minimum average of 0.6. As we have done for the tennis court, I'm going to show you 2 different approaches shown in these schemes. The first one is 8 poles with a lower height, let's say 50 meter, and it's mostly used in the northern part of Europe. And the second one, which is mostly used in the southern part of Europe, which is based on 4 poles, so less poles with a higher mounting height, 30 meter, let's say. The difference is that more poles mean that you can use one side of the pitch for training purpose. So with this layout here, you can turn off half of the pitch, as we have seen with the tennis court, and use only this half for training, or if you don't have to use the entire pitch. The disadvantage of using lower poles is that you need to increase the tilt to reach the required uniformity, and by increasing the tilt, you will increase the glare rating for the players. Of course, lower poles are cheaper, so I mean, you need to find also the balance between the infrastructure cost, the installation costs, and the advantages and disadvantages in terms of glare rating and all of these factors to choose your perfect scenario. Higher poles, so the second layout I'm going to show you, are more expensive, but yes, allow to reduce the tilt and reduce the glare rating and generally increase the uniformity on the football pitch, on actually any sport facility. So let's get back. Let me just open the new Dialax. I need to just open this. No, we don't have to save it. As we've done for the tennis court, we have prepared 3 different scenes, but we will start with an empty, a green field, an empty exterior scene here. Okay, as you can see, it's completely empty. The process is exactly the same as for a tennis court and for any other sport facility. So we have to click on the object button, go back on sport facilities, select the football field. We are going to use a standard dimension and we are interested only on the plane area. So we have to set the total area with the same dimension of the plane area. So 100 meters by 64. And we just have to click insert. Actually, you can choose from this box also the origin already of the sport facilities you are going to use. We want to have it in the origin, so it's 0, 0, and 0. We just have to click insert. And as you can see, as for the tennis court, we have our preset with all the lines and all the dimensions. As we have done before, we have to set the calculation grids. So we have to open the soccer field here. We just have to delete the total area because we're not interested in for this purpose. So just delete it and then select the plane area, which covers the entire field. So we should go and select horizontal in the calculation box. And we want the values to be displayed and not the points. And in the real-time calculation, we want the horizontal. So as you can see, the calculation points only show 0 because we don't have the light in our model. And now we have to insert the lights in our model. So we will follow the exact same process we have done before. Click on floodlight arrangement, select the right photometric you want to use. For this purpose, we're going to use the Modus R1200, which has a higher lumen output compared to the R800, and it is the best floodlights for this application. So we just have to insert and follow the exact same process we have done before. So set the rotation for our floodlights is -90 for C and G max. Remind you that you always have to ask to the producer, which is the correct rotation angle to be inserted in this box. Then we have to go on the arrangement to set up the position. And as I told you before, this is an ideal scenario. I know it can look like easy to do a lighting design for sport facilities, but actually most of the time it's a retrofit. It's not symmetric. It happens that sometimes you have one side with 15-meter poles and the other side with 10-meter poles. Or sometimes it happens that you have 3 poles on one side and 4 poles at the other side. So it's much more complicated process. For our session today, we will only consider the ideal scenario with no environmental limitation and like a green field, complete green field. So we will start with the 8 poles, 50-meter height. So we have to set the height in the project manager box, user defined 15 meters. And in the arrangement box here, we have to set the location. The 2 locations we want, we can choose it. So for example, 35 meter minus 35 meter here and 50.5 here. This is just an example, could be completely different. The symmetry point is already in the exterior scene origin. So we already have our 4 poles. We just have to add the extra 4 poles. Just a quick reminder, you can select the origin, the symmetry point in this box, 5 meters, but we want to have it in the origin. So 0 and 0. So we have to copy and paste. Since we have already set all the characteristics of our floodlights arrangement, we can copy and paste this. So just copy and paste, and we have a new pole with the same characteristic of the first one. For this, we wanted to have it like at the same distance from the center, so 35 meters. And for example, I don't know, maybe -9. So here. Now we have our 8 poles layout, as you can see, 50 meters, 4 each side, everything is symmetric, everything is very ideal here. In order to do this lighting design, we start with 2 floodlights for each pole. So we just have to type 2, number of floodlights here, and 2 number of floodlights here. As you can see, by copy pasting, all the preset rotation are the same for the second floodlights. So the process now is exactly the same we have followed for the tennis court. We just have to move the floodlights, our peak, just to reach our, oh, sorry, this is -90, not 90. Sorry. Okay. So we just have to increase the minimum level by moving the main peak of our floodlights from a certain point to the minimum. We can already see that, just a quick recap, we are interested in 200 lux average and 0.6 uniformity, minimum average ratio. So we already exceed the average illumination level. So we already know that the number of floodlights to reach the average illumination level is right, because we're not like exceeding by 3 times, but just 10%. And we just have to play a little bit around with the aiming to increase the uniformity. So we just have to take 1 floodlights, maybe here, just to increase the minimum. As for the tennis court, Dialux highlight the maximum, which is 334, and the minimum, which is 120 here. So we just have to increase the minimum. We're getting closer and closer to the desired 0.6 uniformity level. We just have to increase a little bit the minimum, which now is here. We have moved it from here to here. It's always like the most critical point are the areas in between the poles. If you are using like 12, 15 or 18 meter poles. So we just have to increase the minimum a little bit and then see if we are going on the right way. Increase it, and okay, we match the required values of 200 lux and 0.6 uniformity with this layout, 8 poles, 50 meter high. As you can see, in an ideal situation where the lighting designer can choose the height and the location of the poles, the process is very quick. We already know, let's say we have experience to already know how many floodlights we need for a center type of facility and how to aim them in order to reach the different classes lighting requirements. Now I'm going to show you the difference between this approach and the 4 poles, 30 meter high poles approach. So this is what we have already prepared for you. So this is 8 poles, 50 meter height. This is light distribution. And here is a 3D false color rendering of the 4 poles, 30 meter height poles. Let me show you the results on the field first. Let's go back into these. As you can see, we have 247 and 0.7 uniformity. Of course, I've spent more time in designing these, so I can reach better results. So 247 and 0.7 uniformity for this layout. The main thing we have to see is the uniformity, which, as I told you before, with higher pole, it increases. Let's say we pass from 0.7 to 0.70 to 0.76. So there's an increase in the uniformity by considering higher pole. Another thing we can take into consideration is the glare. As we have done for the tennis court, we have preset, let me show you into these here. we have preset a certain number of GR observer all the way within the soccer field in the same location and with the same characteristic for the two different layouts. Let's see in the output box, which are the results. All floodlights on, GR. As you can see, they are very low actually, but no one exceed like 45. The limit is still 46, for example. The limit is still 50 for the maximum glare ratio level. Let's keep in mind like the first three, 39, 40, and 42, and let's see which are the results for this. So back to this, 39, 40, and 42. 27, 28, and 31. As you can see, it's a massive difference. This is due to the lower tilt use, so you don't have to like increase the tilt and move the peak of the light directly onto the players. This is an advantage of the 4-pole layout. An advantage of the 8-poles layout is that, as I told you before, we can use half of the pitch at a time. In fact, this is the 8-pole layout full on mode, and let me show you the half mode here. So basically this is dark, it's not used. This is the same pitch and is lighted only at half. This is for training purpose or generally if you don't have to use it, all of it. This is a 11 soccer field. If you want to use it at 7-7, if you have a 7 versus 7 match, you can use maybe half of the pitch and don't have to illuminate all of it. Well, I think that with the football, we have done with the football. I think I don't miss anything here, and we can go back with our presentation. Back to you, Mike, for the second poll.
Yeah, thanks, guys. Just before we move on to stadiums, we want to do a very quick poll with regards to the sports market at the moment. A little bit of analysis from the audience that we have here to understand the effects of the current environment on your projects. So very, very quickly, we just want to understand, are your sporting lighting projects still going ahead? So do you still have projects that are happening at the moment over the next 3 months? Do you have projects over the next 3 to 6, 6 to 12, 12 months plus, or the majority of our projects being delayed? We just want to get a feel and understand a little bit more about everybody's current situation. We know that we've got projects that are actually still running and going ahead right now. However, we also know that some of them have been delayed. So it's just to get a little feel for the market. We're going to post these stats afterwards to say that there is potentially positive sentiment in the market with regards to sporting projects going ahead, and in fact it's not all doom and gloom in the market right now. So I'm going to end the poll because I know we've got stadiums to come and we're getting close to our time, and most people have voted for us right now. We'll just give you another 4 or 5 seconds and I'll close this down and share the results. So ignoring those on the call who maybe it's not applicable to because you're coming from a different part of the industry, it looks like a lot of the projects have been delayed, which is something that we're seeing as well. However, it's great to see that we've still got people with projects ongoing, things happening not only immediately, but over the next 12 months. So I'm taking from that it's still a positive environment that we're working in. And like us, there are still a lot of projects going on across the world right now, which is great to hear. So Marco, I'm going to stop sharing the results, hand straight back over so you can fire into our stadium section.
Yes,
right
that's
now.
Because we're running late. Let's see very quickly like an overview of a big stadium. Of course, a big stadium, what we're going to show you is a UEFA regulation stadium. Let's show you an extract of the UEFA Stadium Lighting Guide. This is just a small extract. It's like probably 90 pages only for the lighting. This is just to show you the difference in between like what we have seen since now. 3 different classes. The maximum, which is class 1, is 500 lux. And now the requirements of a UEFA stadium. As you can see here, the average illumination level for horizontal plane is 1,500 lux, so it's 3 times more than the best class prescribed by the EN. And we have the requirement for 2 different uniformities. U1 is the uniformity, minimum, maximum uniformity. This is a very important uniformity because if you think to be a player on a very important match, you cannot, you're running within the field and you cannot pass from an area with, I don't know, maybe 2,000 lux from this area to another area with maybe 700 lux. Because the difference, there's a very big difference in between these 2 levels will like blind you. You won't have a very quick, I mean, your eyes won't be adapted very quickly to these big changes. The second uniformity is the one we have seen so far. It's the minimum average uniformity, which should be at least 0.7. A new requirement which is introduced by UEFA regulation is the vertical luminance over the 4 main axes. So it's 0, 90 degrees, 180 degrees, and 270 degrees. And also for these 4 different degrees, we should have the same average illumination level, the same minimum level, the same uniformity level. The prescriptions are here. You can see it's the average should be at least 1,250 lux. The minimum should exceed 700 lux. And the 2 uniformity, the U1 vertical, here it's only 0 just because of the space, but should go from 0 to 270 degrees, which is U1, which is the minimum maximum ratio uniformity should exceed 0.4, and the minimum average uniformity should exceed 0.5. We have skipped some of the requirements because they're very long to be explained. It's very complicated to be explained in these sessions. Something which is interesting to show you is that the requirements here also includes the color rendering index, which should exceed 80. The color rendering index, the CRE, gives us a number which goes from 0 to 100, which gives us the fidelity given by the light source. The fidelity of the color given by the light source is a parameter which is related to the LEDs and not the floodlights as a system, but only to the LEDs. And as I told you, is give us a number of the fidelity given by the light source. This is mainly for a camera broadcasting purpose. The glare rating should not exceed 50, as we have seen so far, and the maintenance factor shall be set at 0.8. I forgot to tell you that for all we have seen so far in Dialax, the maintenance factor was set at 0.9. Since the average usage per year is between 500 and 1,000 hours for a local sport facility, and 0.9 maintenance factor is definitely the right value for this. So let's move on. I just want to show you, let me just open a new Dialax. Of course, we have already prepared Dialax file with the big stadium. It would take like a massive amount of time to create this in, because as you can see, it's kind of complicated. This is just to show you and to give you a general overview about the difference from a local sports field and a big UEFA stadium. As you can see here, we have, let's go with the 3D views. We have modeled like a big stadium, a donut shape. We have modeled all the stands inside. You can easily use some slopes to do this. I mean, everything is inside the object options here in Dialax. You go for standard elements. You have extrusion volumes, wedge, and slopes, and so on. So you can easily use these to create this model. The main difference here is that we have used the main trusses on the roof to install the floodlights, and so exactly at the top of the pitch, and these help us to reach the average illumination level for the horizontal plane. What we need in order to get the lighting requirement for the vertical values is to install some floodlights under the roof over the stands. Let's go on the 3D view. As you can see here, we have some floodlights which are installed under the roof over the stands. Because as you can see, let's move here. We need this angle in order to reach both uniformity and average illumination level for the the 4 vertical directions. Another difference is that for like a big stadium such this one could be, we have also insert 2 cameras. The cameras can be selected in sport facility box, object, and sport facilities here. Here in this box, you can set all the dimension, the height. All this information are like provided by the customer, the final user, so the owner of the stadium. Because as you can understand, each stadium has its own dimension, its own stands, maybe 1 ring, 2 rings. And so the camera location are very important because they are installed at different height, at different locations, and should be like positioned according to the instruction provided by the customer. In the UEFA regulation, there are some suggested location in order to have the best views, but of course, as you can understand, each situation has its own infrastructure, so as the space in a certain area or another one. Another difference, big difference actually, is that UEFA regulation prescribe the location of the grid points, of the calculation grid points and GR observer, and all the grid points should be at 1 meter high instead of the ground level. As you can see, the grid points should stay at the sideline, touch lines, and then there's a 12 by 8 point grid, which should follow a precise dimensions. Also, the EN regulation, the one we have seen for the football field, prescribe a certain number of points, but they don't have to follow the sidelines and touch lines. So basically, I think we have done for today. We're running out of time, like 2 minutes late. So if you have any questions, and we have time, I don't know if we have time today, but for every question you have, just type us and we will reply you as soon as we can, email tomorrow or today if we have time. Mike.
Thanks. Can you just flick back to the presentation for me? So we've had a number of questions comes in, but actually we've been answering these live as we go. So everyone who's asked a question, Paolo in the background has actually been firing them back to the team. So what I want to just quickly do is, if you can click to the next slide, is just a reminder, anybody who's joined us from the aviation industry, we have a fantastic webinar coming up in a couple of weeks with our partners and friends in the industry, Honeywell and TKH Airport Solutions. Will be sending you all from the aviation sector an invite to this. It is going to be an incredible session. And of course, when you do leave the session right now, you'll get a little pop-up that asks you about whether you would answer a survey for us. Please do fill in the questions. It helps us understand a little bit more about how the session went and our future sessions that we want to design for you. So as we answered all the Q&A as we went along, I'm going to bring it to a close, and I want to thank Marco. That was a fantastic session, really interesting.
Thank you.
I think we're going to have a request to go into a little bit more detail into some of the more advanced parts of lighting design, especially within the sports stadiums, but we can do that session in the future. And a massive thank you to everybody who joined us once again today. It's fantastic to have so many people from all over the world. So thank you all. Enjoy the rest of your days. Stay safe, and we look forward to welcoming you onto future sessions.
Thank you all, and see you at the next webinar. Thank you.
Bye-bye.
Bye-bye.
Bye-bye.